Mr. Gunick, I really don't get question number 18.
Which question is number 18?
It's this question.
Okay, so we have to find the perimeter of the shaded area, all right? And what information are we given?
It's 5 centimeters of radius.
Okay, so the radius is 5 centimeters, and what else?
The angle is 1 radian.
Very good. Now, if we're going to find the perimeter, how many parts to the perimeter are there?
I guess here in this part.
And what else?
Oh, this part too.
Very good. So there's going to be 3 parts in total. The 2 radiuses, or radii, and the big arc length. This part here. Now, again, what's the radius?
The radius is 5 centimeters.
Okay, so this first part will become 2 times 5, and again, plus the big arc length. Now, this is going to be the problem. How do we find that part of the circle?
I guess you get this length times pi.
Okay, so pi times the diameter, or 2 pi r, what is that going to give us?
The total length of here.
Right, it's going to give us the total distance around the circle, but we don't want the total distance, do we?
We don't.
What part do we want to get rid of?
This part.
Right. So we're going to find the total length of the entire circle, but we're going to minus this arc length here. Now, what's the formula for the arc length?
Arc length is theta times radius.
Very good. Okay, so let's take a look at this down here. So the big arc length is going to be the total distance around the circle, which you said is 2 pi r, and we're going to minus the small arc length, which is going to be theta times r. Now, in this case, what's theta?
Theta is 1 radian.
Very good. And what's the radius?
Is 5 centimeters.
Okay, so putting 5 in for the radius and 1 in for the angle, this is what we get. And what does that simplify down to?
It's 10 pi minus 5.
Very good. Now again, remember that we were solving for just the big arc length, so the outside part. And so let's take this and put it up here. And now we have 10 from 2 times 5, and then again the big arc length that we found down here. And what does this simplify to?
Oh, it's 10 pi plus 5.
Very good. And let's not forget centimeters because we're measuring perimeter.
Yeah, don't forget. Oh, Mr. Gurnick, I didn't get number 19.
Okay, let's take a look at question number 19. Okay, so for this question we have to find both the area and perimeter of a shaded area. Notice that the information given to us is what?
Radii, 1 centimeter and 4 centimeter.
Okay, so very good. So this is going to be 1, and then from O to A or O to B is going to be 4. And what about the sector angle here?
It's pi on 3 radians.
Very good. And just a quick little test for you. What's pi on 3 radians in degrees?
It's 60 degrees.
Ah, very good. Now, we're not going to use 60 degrees at all, but I just want to ensure that you're able to convert between radians and degrees very quickly all the time. All right? Now, Risa, what do you think is going to be easier to do, area or perimeter?
Perimeter.
Okay, so let's start by doing the perimeter part.
Okay.
Now, to find the perimeter, how many parts are there?
4.
Right, and can you just quickly point to them for me, please?
1, 2, 3, 4.
Very good. And so what you're going to notice is that these two here are arc lengths, and you can probably tell me these two values right away.
3.
Right, and how did you get 3?
4 minus 1.
Very good, from the radius. Now, again, as I said earlier, these are going to be arc lengths. What's the arc length formula?
Theta r.
Very good. So this arc length formula is theta r. And we're going to name these arc length 1 and arc length 2. So in our work, it's not very confusing for people reading our solution. Now, to do this is just simply we're going to start by writing down the formula. So start with L1 is equal to theta r. But for L1, what's theta
Pi on 3.
and what's the radius?
1.
Very good. So put that information in, and what does that simplify to?
Pi on 3.
Very good. And you set it pi on 3 as a cool kid would. Okay? Now, once you've finished L1, L2 is the exact same thing. Okay? So L2 is the same formula, theta r. But now in this case, what's theta?
4.
The radius is 4, but what's theta?
Oh, pi over 3.
Right, it doesn't change, but say pi on 3, remember?
Right.
Okay, so plugging that information into the formula, we have pi on 3 times 4, and what does that simplify to?
4 pi on 3.
Very good. So here we have the two arc lengths, L1 and L2, and we already know that these were 3's, and so our perimeter is now just the sum of all 4 parts. And what does this simplify down to?
6 plus 5 pi on 3.
Very good. And centimeters because it's perimeter, and we're finished. Now, let's move on to the area.
Okay.
Okay, Risa, let's now look at the area. In order to find the area of this region, what formula are we going to need to use?
Oh, I know. It's 1/2 theta r square.
Very good. 1/2 theta r squared. This is the sector area formula, right? Now, how are we going to find this area using this formula?
We have to find this one and then subtract this smaller one.
Perfect. Okay? So in words, just let's write this down. So as you said, we're going to find the large sector area and we're going to subtract the small sector area. Okay? So in formula form, this is going to look like the following. There. Okay. Now, notice that the theta is the same in both parts because they both, the small circle and the large circle, or the small sector and the large sector, share the same angle, don't they? And what was the angle?
Pi on 3.
Right. And the radiuses now are going to be different. What's the radius of the large circle?
It's 4
And what about the small circle?
and then 1.
1. And so putting the information in, we get the following. Okay? Now, what does this first part for the large sector simplify down to?
16 pi on 6.
Very good. And the last part?
1 pi on 6.
Perfect. So what we get here is 16 pi on 6 minus 1 pi on 6. And how does that simplify down?
15 pi on 6.
Perfect. And what's the last thing we can do to this?
Reduce.
Right. Reducing it, we get
5 pi on 2.
centimeters squared.
Right.
Okay. Excellent.
Yay.